Welcome to Group Theory for Data Scientists. This is a series of advanced mathematics for data scientists. We will cover category theory, group theory, representation theory, graph theory, and manifold and Lie theory. In this video, we will cover group theory. A group is a set G with a binary operation that has the following properties. Closure. For every two elements, we can combine this, and this is in the group. Associativity, identity, and inverse. Let's see an example. The integers with the addition operation. Adding two elements is again an integer. Associativity is obvious. The identity is 0, and the inverse of an element is the minus of that element. The group of a rotation of a triangle. We can rotate a triangle around the center, and we can get back to identity by 3 rotation. Or we can flip the triangle. These symmetries form a group called dihedral group D3, which has 6 elements. Okay, so the dihedral group had 6 elements. The integers have infinity many elements. This is the order of the group. The order of the element is the number of times that we have to do that element and get back to identity. For rotation in the triangle, we do it 3 times. So this is the classic example of groups that we covered some of them. Consider the group Z6 under the addition. If we take the element number 1, this is a generator, because by repeated iteration we can get all the elements of the group. But if we choose an element that is not 1, we get an subgroup, like number 2. In Z6, step 1 touches every element, but step 2 only touches 3 elements, which is a subgroup. Permutation group is a group of rearranging distinct items. Suppose we have 4 items. We can switch the place of these items. We denote this switching by an cycle, which tell us which elements goes to where. Here, this cycle means 1, 2, and 4 trade places, but the element 3 state is fixed. Let's have a look at one of the theorems in algebra, Lagrange theorem. In order to understand Lagrange theorem, we have to understand a coset. A coset is just a subgroup shifted by an element. And the Lagrange theorem says we can count the number of the elements of the group by counting the number of the subgroups and the elements in the subgroup. Suppose we have the group Z12. 0, 4, and 8 is a subgroup. 1, 4, 9 is a subgroup again, and so on. So we have 4 subgroups. This 4 subgroup partition the group, and each subgroup has 3 elements. So the total number of the elements of the group is 12. We had 4 subgroups, each subgroup had 3 elements. We can form a quotient group by these cosets. The number of cosets form a new group, which has order 4 in our case. Let's have a look at homomorphism and isomorphism. For this, we have to know what the kernel means. A kernel is a mapping that sends the elements to the identity. Consider these two groups, the group Z6 and Z3. In Z6, we can send multiple elements to one element in Z3. The kernel here is 0 and 3, which goes to the identity. And these are the same cosets. So by collapsing the cosets, we get an isomorphism, which means a one-to-one map. Group action. Group action is also a new concept, which tells us how we can count the number of symmetry of the group. We have to get to know what an orbit and stabilizer means. An orbit is where an element can go. A stabilizer is what can fix that element. So the orbit of one in this square is all the elements. It can go everywhere by rotation, and its stabilizer is the identity and the flip through the diagonal. So number of the elements of the group can be counted by this theorem. The orbit is 4 elements, the stabilizer has 2 elements. And we can build new groups by direct product. Let's see an example. The group Z4 is a cyclic group, but we can build a group at the same order, with the same order, but it is not cyclic. This group is like a grid, and it is a product of 2 groups. Here you can see the group Z4, and this is our direct product group. In the parentheses, we show element of each group. The first element is from the first product, and the second element from the second product. But you see these objects are different. So direct product built new groups from old ones.